Okay, so in this lesson, we're going to be talking about parent functions and transformations. Now, transformations shouldn't be new to you. You should have done it before with functions. And we're just going to be doing the same transformations as before, that you've done before, with like cubic functions and quartic functions. Those are the names of the functions that have threes, power degrees threes, and 4. Now, we're just going to start basic. Now, everybody has a different approach to these, but we're going to go with my approach since I'm the one talking. G of x is equal to this long thing here. So the first thing you would have to do is recognize what is the parent function. The parent function just means what is the function that we're going to be changing around. So if this had a sine or a cosine, we'd say it would be a trig function. But in this case, I can see the main function is x cubed. So my parent function is f of x equals x cubed. So I'll recognize that first. And then I can see, okay, inside where it should just be an x, there's a bunch of things that's happened to the x. And outside of the cube, we have some things happening. So remember, outside f of x means vertical changes. And inside f of x is horizontal changes. And also remember that horizontal, unfortunately, always lies. i.e., it's always, they say that the equation says one thing, it's always backwards. Okay, but vertical never lies, always honest. Okay, so actually it's pretty easy to state the transformations. Oh, one more thing, if they're multiplication, that is going to be a stretch. And if it's adding or subtracting, that is a translation, which you probably already know. Okay, so let's look at our function, which I'll just list them maybe over here so you can still see them. So x cubed is let's do the vertical first. On the outside, so there's a cube there, that's all inside, and this is the two things on the outside. So this is multiplied, so that's a stretch. And there's also a negative. A negative multiplication, like a negative with our number that we're multiplying, is always a reflection. So it's a vertical reflection. So we say reflection. So it's a reflection vertically, meaning this way. So if I was to draw a little thing up here, vertical reflection means it's been reflecting that way, which is a reflection in the x-axis. It almost seems a little counterintuitive because it's a vertical reflection, but it's verticals are always in the x-axis. Then we have a vertical stretch. We can call it a vertical stretch, or I already have vertical here, so I'll put stretch. Factor 4. And then vertically we also have a translation, meaning we're just going to move it up because it's positive 5. Okay, so that's my vertical. Now horizontal, we're going to have, that's what's happening inside. Now remember, it's always lying, all except for the reflection. Reflection, you can lie, it just flips back and forth. So the negative here with my 3 indicates that we have a horizontal reflection, which is reflecting things this way over the y-axis. So reflection in y-axis. And then we would say, okay, what looks like a horizontal stretch of 3, but we know it's lying to us. So instead of multiplying by 3, it's like dividing by 3. So what we do to make that easy, when the multiplication that occurs horizontally is always going to be the reciprocal, meaning it's flipped over. So for example, in this case, now, there's a lot of controversy about the word stretch, and I've come across this in my many years of teaching math. I never use the word compression because obviously this is going to be a compression because it's going to, well, I'll write down the stretch first. I'll do that first. So horizontal stretch factor 1/3. Now obviously a stretch of a third, when you multiply things by a third, they get smaller. So it's actually a compression of 3. But if you start using the word compression and you have to flip it upside, it's like double negatives happen and it's confusing. So always use the word stretch and just always use the word stretch and always flip over the number and you'll be right every time. The other thing that's going on here is a translation. So we have a horizontal translation. 2, now it looks like it should be 2 to the left because it's negative, but it's actually going to be 2 to the right. And that's the list of the transformations for that one. Okay, let's flip the paper up a little bit. Okay. All right, so now what we have here is a bit different. They've given us they tell us the parent function. The parent function in this case is x cubed, although we could have kind of guessed that anyway by looking at it, is sketched below. Find the equation of the transform function. So when we want to find the equation, we know that the base function is going to be a cube, like the one above. We're going to have to add in all the translations and the reflections, etc. So the first thing I do when I'm going from a graph is I look for reflections, either way. Because you can just look at the graph. You know, we know what the cube graph looks like. It's like, goes like this, right? And we look at it and say, has it been reflected? Well, I would say yes, it has been reflected because it's not going like this, it's going like this. So you can either consider that to be a reflection in the x-axis or a reflection in the y-axis. It doesn't matter. Either one would be correct. Now, you don't want to say it's reflected both times, because if you did that, then it would be reflected back to the original, which it is not. So we're going to say reflection in, doesn't matter which axis you say for this one, it's going to be right. So I'm going to say in the x-axis. So we'll go with the vertical. So we know it's reflected, so now we just know to put a negative there, and that's taken care of. The second thing we're going to look for is the special point. Now, our special point, what I mean by that, is the 0, 0. Now, the reason that is such an important special point when you're trying to find an equation that has been transformed is that a stretch, either vertical stretch or horizontal stretch, which we know is multiplication, will never affect this point because that point is 0, 0. And if I multiply 0 by anything, whether it be a half or 100, it's still going to be 0, 0. So the only thing that can move a 0, 0 point somewhere else on the graph is a translation. If I reflect that, if I multiply that, it's always going to still stay right there. So the first thing I'm going to do, I'm going to look, it's easy to recognize, I'm going to go over here, there's that point, but it's not at 0, 0, it's at 4, 6, meaning it's been moved over 4 and up 6. So that's the only way that point can move from here to here. Stretching and reflecting will not move it. So automatically you know 100% sure it's been translated. So I go to the translations because it's easy to find those from that point. Translated 4 units to the right, 6 units up. So we're just describing exactly what's happened to the graph. So right now, we know that that point that was there is now here. Okay. The next, we know it's been reflected because it's not going like this and this, it's going like this. So we've already taken care of that. The next thing we look for is those second special points. And we should know them by now because I've graphed them a few times here for you. The next one should be going over 1 and up 1, right? Over 1 and up 1. Well, ours is going the wrong way, but we already said about the reflections. Over 1, it's not going over 1 to the next special point. What is it going over? It's going over 2, from 4 to 6, that's 2. And down, how far? Down 4. And the same thing over here, over 2 and up 4. It should be going over 1 and up 1, but it's not. So that means that is where the stretch has happened, right? We've made it taller and wider. So we've stretched it 2 to the right, 2 to the left, so that's a horizontal stretch of factor 2, and a vertical stretch of factor 4. So once you have all the things listed that have happened to our graph, now it's easy to write the equation. So just to review quickly, you look for the reflections, that's easy, you just look at the shape of it. You look for that special point, the 0, 0, where is it moved, because that will have to be automatic translations. Then you look for the second special points, and you say, oh, are they 1 and 1? Because if they're not, that means they've been stretched. So now all we have to do is write the function. Okay, so remember, the inside is the horizontal and the outside is the vertical. So vertical, we've said reflected in the x-axis, so that would be a vertical stretch, or a reflection rather, to go with our stretch, which is a vertical stretch of 4. Now remember, it never lies to us on the vertical. In this bracket, we're going to put everything that happened horizontally to the x, and it's a cube function. And we might as well write in our our vertical our translation too. Here, it moved up 6, so plus 6. It's pretty straightforward in the vertical direction. So now I'm going to put inside here, adding or subtracted to my x is going to be my translation. To the right 4, but don't put plus 4, because we know that it has to lie to us here in the equation. The equation always lies. So the equation is going to say minus 4, right? Because that would say, we know that would make it move to the right 4. And our horizontal stretch of factor 2, we would think, oh, I'm going to put a 2 here, but no, it's lying. This equation has to lie. So we put a half. And there we are.